Hello, this is Professor John Baugh, and we are starting another exciting session here of C++. Today, we're going to go over classes, objects, and strings. This is for the second lesson. The chapter is Chapter 3 in the class textbook. I have uploaded the slides. But the slides have a kind of a specific example they go through in the book called the gradebook example. And I'll do a separate example. It's a little bit more simple and clean cut. And I'll go through our supplemental notes here. Instead of going through the 90-some slides, I'm going to show you how to remind you how to start a project in Visual Studio and work with the solution and the source files. So again, it's Chapter 3 in the C++ How to Program 9th edition, and we're covering classes, objects, and strings in C++. First, we're going to go over the basics of classes and objects. This is a fundamental concept, and you've got to understand this and remember some of the terminology here because it's very important in C++ and in other programming languages as well. We're dealing with what we call an object-oriented programming paradigm, an object-oriented paradigm. So what we saw last week, a little bit of an introduction just using the main function. We saw that I could deal with different programming output statements, very simple ones, and I could, if I wanted to, break them up into multiple functions in the same file. I wouldn't have to use a class, so I can think of solving a problem by dividing it into smaller components, and these components could be functions, but they could also be objects. So with object-oriented programming, we deal with the terms class and object quite a bit. Now, some literature and some people in the industry will use the terms classes and objects interchangeably, but they're really not the same thing. A class is a programming construct that acts as a blueprint from which multiple objects, also called the class's instances, or just instances, can be created. Classes are defined in terms of their member functions and their data members. So the member functions, in a lot of programming languages, these are called methods. So if you're coming from a Java world, the functions that live inside of a class are called methods. These describe the behavior that the object of the class participates in. So what do they do? Can you ask the object a question through a member function, or can you ask the object to perform a particular task? But there are different types of member functions. We have observers, also called accessors or get functions, and then we also have mutators, which are called updater or modifier or set functions. So the observer functions are member functions that just return information about an object, but they don't modify anything. So they don't modify anything. The mutator functions, on the other hand, allow you to access in a controlled fashion and change the data inside of an object. So the data members, on the other hand, describe the attributes of the objects. All right, so they don't just perform certain types of behavior. They instead are descriptors, so they're more like nouns instead of verbs, where the member functions are typically verbs, like do this, get that, set that, calculate this, etc. The data members are just attributes of the objects. So what does the object consist of? So the data members have attributes. Let's say we have a dog class. We might have attributes like name, weight, age, and breed. Okay, so those would be data members. Also, which are technically member functions, we have constructors and destructors. A constructor is essentially a member function with no return type. It's not even void, so it doesn't return anything, and you don't even put void in front of it. It has the same name as the class. It is for the purpose of setting any default values or doing any setup connections in somewhat more complicated examples of, say, a file accessing program, or maybe you have a program that connects to a network program or another network program, or accesses a database. The destructor has the same header syntax as a constructor, but it also has a tilde, which is the curly thing right here. It's right above the tab key and to the left of the 1 key on the keyboard. This is in front of the destructor name, so it's the same name as the constructor, except it has a tilde in front of it. Alright, so you try to remember these. Classes are general descriptions like a blueprint of a house, and objects are like actual houses built from the blueprint. Okay, so that's the difference between classes and objects. Okay, we'll get to some actual code in just a minute, but we're going to look over a few more details. The next thing are the access specifiers, also called access modifiers. These are restrictions on the member functions and data members. You create restrictions on how much access the outside world has to your class by using the access specifiers, access modifiers. Like the name suggests, they allow you to specify access to your class or object. There are 3 access specifiers in C++, public, private, and protected. But for right now, protected would be a little bit difficult to explain until you have a little more experience with classes, so we're going to deal with public and private for right now. Public is the specifier that indicates that anything within or outside the class can access the data member or member function. If you make a member function called set age, and you intend on it to set the internal age of the object in question, then you can call it from the outside world. In other words, if you have a separate class and then you also have main that's accessing your class, an object of your class, it can call the set age member function because it has access to it, if it's public. Now, if it's private, if we have data that's private or even member functions that are private, this means that only the class can access that data or member function. Note that it is typically the case that data members will be in the private section and most member functions will be in the public section. But data and functions can go in either private or public sections. Additionally, note that you can access private data by using a public member function to do so. This is typical behavior of what we call a get member function. It's designed to get data from inside the class. Likewise, you can modify the internal private data members of the class through a set function, okay, through the set member function, what we call the mutators or modifiers. These allow you to pass information and modify the internal data of the object. You might wonder, well, why don't we just make the data public and then anyone can access it? Well, there's a very good reason for that. It violates and breaks what we call information hiding. It's part of encapsulation, which is a pillar of object-oriented programming. We will talk more about that when we get into more on classes in a couple weeks. But basically what this means is you have no control about what the user does with your private data if you make the data public. So let's say you have an internal piece of data called age. Well, if the client program, the program that's using your class, decides to create an object and then set the age to -5, there's nothing stopping it if you have private data or public data. If you have private data and then you force them to use a member function to access that data, then you can restrict what they do. You can say, you can use what we call control structures, which we'll learn about in a week or so, to prevent the user from accessing the data in a way that they're not intended to. So you could say, if they try to enter a -5 for the age, then you could either maybe say that's an error, or you could set it to 1 by default or whatever you want. So you would never allow them to enter a negative or 0 value for age. All right. Finally, strings. Before we move on further, we must make note of a class that is defined for us to use. So someone else, other people, who made this the C++ library, created the string class for us. Strings are just sequences of characters, but the class string that's provided for us is actually quite sophisticated. Okay, There are many member functions available for manipulating strings, and strings in C++ are what we call mutable, meaning that you can change them or a portion of them even after they're created. To use the string class, which is part of the C++ standard library, you have to use the string header, and you have to use the std namespace just as with IOStream. So if we were to do, let's do an example here. I'm going to open up Visual Studio here. I'm going to create a new project. And I'm going to make sure we're under C++ here. Click on C++, make sure it's a Win32 console application. I'm going to browse to the appropriate folder here. I don't think I made a work directory. Let's do that. Alrighty. And I'll call this Lecture 2 code. Hit OK. Right here, the Win32 application wizard pops up. And I go to Application Settings, and then you want to check Empty Project. Make sure it's Empty Project is checked, and that you also have Console Application right here. You want to hit Finish as well when you're done with that. So then it will create an empty project here. You have an empty project with no source code here. I'm going to create a single source file to start off with where main will go into. So you right-click, go to Add, and then I'm just going to say New Item. Make sure it's a .cpp file. And this one, you really don't have to call it main. You can call it driver or horse or sausage, whatever makes sense to you. But I usually call my main, the file that contains the main function, main.cpp. So you can click Add or hit Enter. And we're going to put our default code here that we've used before. Okay, this is the skeleton program that we've used before. If I want to use strings, I have to include string here. So just to show you how I might use a string data member, or not data member, I'm sorry, the string data type, I'm going to type string and say my name. I'm going to say equals, and then in double quotes I'll say John. You can use it with cout. You could say my name is, so that's a string literal, then you separate it by the stream insertion operator. Then I can use it as a variable. And then I'm going to put an indel at the end, which, as you recall probably from last week, causes the insertion point, the cursor, to move to the next line. I'm going to go to Build Solution. Then I'm going to go to Debug after it's done building. Go to Debug and then go to Start Without Debugging. And it brings up our console application running here. It says my name is John, and then the press any key to continue if you recall. That is created automatically by the environment. Now if you're trying to execute it outside the environment, or you're doing a start with debugging, just a regular debugging statement, on Windows you can actually do this. This is just a note here. You can do system pause, and that will cause it to pause, so it doesn't just, the black screen doesn't just pop up and go away. So for those of you especially coming from a Java environment or not familiar with coding, the system pause command is actually quite useful. Okay, but we don't need it if you're doing a start without debugging. It shouldn't close automatically. All right, and if you're dealing on a non-Windows system, the best suggestion I have for you is to create a temporary variable, like an integer or something, and then do a cin statement. It's a dummy variable. It's just waiting for you to type something, any key. So like a string or a char, usually a char, and then do a cin statement at the end. So what it's going to do is the program's going to wait until you hit some sort of key. All right, so that's with strings. Now, to get into real object-oriented coding, we want to create a class. Now, the example I do in the supplemental material involves a spaceship, but I'm going to do an example for you involving a. Let's make sure I didn't do this one too. We'll double check. Got the spaceship here. I'll do an example that involves a rectangle. Okay, we're just going to make a class that represents a rectangle. So a class, again, is the blueprint for an entity. It doesn't have to be a real, life entity that you can interact with directly, but sometimes it'll represent a concept, like an idea, or sometimes it represents a bank account. Sometimes it represents a physical object. Like in a graphics program, you would definitely have something that represents maybe a rectangle or a triangle or circle or what have you. So what we're going to do here is we're going to create this rectangle class. To do so, we're going to do a technique called separate compilation that requires us to create 2 additional files in addition to our main file here. The main file is called the client because it's just going to use our rectangle that we're going to create. So what you're going to do is you're going to go to the header files right here. You're going to right click it, go to add, then go to new item. And for the header files, make sure it's under headerfile.h. Okay, this is what's going to be called the specification file. Okay, header file or specification file. Some people call it an interface file, but we're going to call this C rectangle. Now you could call it just rectangle if you wanted to, but it is conventional in C++ to put C in front of all the class names so you know automatically that it's a class. You don't always. For example, the string class obviously does not have a C in front of it. And again, it's not enforced by the syntax. It's not a syntax enforcement. It's just a matter of convention. So I'm going to click add. So that'll create the crectangle.h file. It's a blank file. Under source files, I'm going to do the same thing. Right click, add, new item. Now this time you want it to make sure that's under CPP file, just like the main file we created. This one is going to have the exact same name. You should make it the same name and the same case as well. So I'm going to make this one crectangle.cpp. This is going to be called the implementation file because this is where the actual implementation of the member functions will go. Okay, I'm going to click add now. So I've got this and this. I'm going to start with the .h file. In this case, I'm going to say class C rectangle. This should match the name of the file. We've got C rectangle, and in Java you would put the keywords public and private in front of each of the data members or member functions, what they would call in Java the fields, which would be the data members, or the methods, which are the member functions. But in C++ we make sections basically. You have public and private. So in the public section we're going to put our member functions, and in the private section we're going to put our data. For the rectangle we just need the width and the length. So int width, int length. Good. Also, another thing to note about the member functions in C++, or the members in C++ in the class definition, is that not only do you have these 2 sections for public and private, there's also a semicolon at the end of the class definition, which is not the case in a language like Java. So in the public section, we're going to make the header basically the function prototype, or header, for the constructor. Okay, this is called the default constructor. It's called automatically when you create an instance of this class. Okay, which we'll see in a minute. We're actually going to use this class. So right now we're working on the blueprint. What does the blueprint look like? What does the rectangle look like? That's the question we're asking. In addition to this, we're going to have the setters. So we're going to say set width. That's going to take a parameter. Okay, this is the data that's going in. We're going to call it W for width, and then we're going to have set length, int len. Okay, now we're going to define getter functions. This time we want a function that returns the width, a function that returns the length, and then we're going to make a special one in just a second. But let's do this. So what we're going to do is we're also going to create the getter functions. So we've got the setter functions up here. Okay, these are called mutators. And you've got the getter functions. Those are called setters. I'm sorry, getters are called observers or accessors. So the getter functions, since you've got 2 integers here, a width and a length, You could make them doubles if you wanted to use more accuracy, but we'll make them int just for the simplicity's sake for now. I'm going to say int get width, and this one does not need a parameter because you're not sending any data into the object. You got to think of yourself as the object. Do you need data in order to tell the outside world what your width is? And the answer is no. So you've got int get width. Now we could end it at that, but in C++ you can put the keyword const after the member function name, and what that does is you're basically signing a contract with the compiler and saying, if I put const after anything, that when I implement this function, this get width function, it's not going to modify any of the internal data members. So in other words, if I try to set width to something or set length to something, it's not going to let me do it. The same thing with get length, doesn't need a parameter, and you've got const there. Also, we're going to add a third type of getter function. This one, again, does not modify any internal data, but this one is going to be made from a calculated value. It's going to be called get area. Right? So that one's going to calculate the area and return it. So I've got all these member functions that I need to implement. I do not have any implementations for them. In other words, I've not told the class, well, what do these actually do? So I'm going to save this file, Control S, or File Save. And right here, I'm just going to copy some of these, and then I'll show you what it looks like inside of Rectangle.cpp. First thing I need to do is say include Rectangle.h, so that it knows where it gets the specification from. And now I'm going to implement them in this separate file. So this is the implementation file, the .cpp file. So the .h file, again, this is the specification file. Specification also called the header file. All right. This one over here, the Rectangle.cpp, is called the implementation file, because we're actually implementing. Alright, so I'm going to paste all that stuff I just gathered. Here's a little trick here. I'm going to highlight all this. If I want to delete the tab that's there, I don't have to do it one by one. You can hold down Shift on the keyboard and hit Tab. Shift Tab, and it'll get rid of all the additional tabbing that you may not have wanted in. To actually implement these, I have to tell the compiler where each of these methods or these member functions come from. So what class do they live in? Well, this is easy. First you put the return type, and since the constructor has no return type, you skip that, and then you just say the name of the class. In this case, it's the same name as the constructor, so this might look a little weird. Then you give it a body. Okay, this is the body of this constructor here. The set member function here, set width, you have to preface it with the name of the class and then these two colons here. The colons on the key to the immediate right of the L key on the keyboard. You put two colons there. This right here, when you have two colons, it's called the scope resolution operator. So we've got this. We've got two colons. It is called the scope resolution operator, because it basically says what class does it live in, what's my scope, and you're telling it, you're resolving the scope with the scope resolution operator. Same thing with set length, very similar here. After the return type, you put the name of the class. So if you guys are familiar with Java, if you've done any Java, then this might look a little peculiar, but it is required in C++. So get width, I'm going to do the same thing, Rectangle, scope resolution operator, and same thing down here. For get length, Rectangle, scope resolution operator, give it a body. Same thing here, Rectangle, scope resolution operator, and then I'm going to give it a body. Okay, let's actually implement these. We now have the empty bodies one by one. That's the best way to do it. I say design your class carefully, go through here, and come up with what parameters do I need. In other words, if I need any parameters, does any data need to go into the class for me to make use of this member function? Then the second thing is, does the member function actually modify the internal data of the class? And if the answer is no, then you put const at the end. Now, do you have to put const at the end? No. However, the compiler will not flag it if you try to modify data inside of these functions. So it's basically good software programming practice if you put the const keyword afterwards. Alright, so for the constructor, this is called automatically. This is called the default constructor. It's called automatically when the class object is created, when object of the class is created. So let's say for this, I'm going to set the internal width and length equal to 1. That's all I'm going to do. So I'm taking my internal width, setting it to 1, taking the internal length, setting it to 1. Now for set width, this is very easy. I'm passing data into the class, basically, or into this function of the class. I'm naming it the parameter w. So whenever you have a parameter, it basically acts as a local variable to this function. Just like if you declared a variable inside of main, it would be a local variable to main. But in this case, we're dealing with a class. Main in C++ does not live inside of a class. Notice there's no class definition outside of main. So if we go here, I'm setting my internal data width equal to whatever the user passes in, which is w. Same thing with length here. Length equals len. That one's set. Get width. For a get function, you have a return statement, and you're returning the width in this case. Return length. And then for area, this one's a little bit different here. You might think, well, how are we going to return the area? We don't have a data member called area. Well, how do you calculate the area of a rectangle? Area equals the length times the width, right? For a rectangle. So we're going to return length times width. It's very simple. Now you might ask the question, why don't we have a piece of data called area, and then we can just return area? Well, although you could do that, that's actually an additional variable you don't need, so it makes the class bigger than it needs to be by adding additional data that it needs to track. It also tends to force you to have something called, or to experience a situation in which you will have what's called stale data. That means every time you changed the width or the length, you would have to also update the internal data member area. Otherwise, you would get stale data. The area would not reflect the current width and the current length, so that could be confusing. So it's really a waste. So since area can be calculated from data that we already have, you just return the length times the width. So you don't need a separate variable for that. Now if we wanted to, I could do something like int area equals length times width, and then I could return area as a local variable here, but we're not going to do that. So I'm going to delete that. I just skip a step here and don't need the extra variable, so I do this. Alright, now we've got our class defined here, and now to actually test the class, I'm going to go over here to main. To have access to the class, I have to include, and then I'm not going to use the angle brackets because this does not live in the standard namespace. We're going to include crectangle.h with double quotes around it. Okay, it's not included in a namespace that we have direct access to without resolving it or without adding it to the project properties. That's why these use angle braces, because it's got a directory it automatically looks in. Now if we told it, hey, look for header files in this directory, then you could put angle brackets around it. But we'll just use the double quotes because it knows it's going to look in the same folder as this main file is declared in. So I'm going to get rid of the code I had there with the string in it. I'm going to say crectangle, my rectangle. Alright, so that declares my rectangle. If I say cout my rectangle dot length. Okay, I'm going to put a little multiplication symbol here, and then say my rectangle get width equals area of, and then my rectangle dot get area, and then an end line character. Now I could separate this onto separate lines if I wanted to. In fact, I'm going to do that here. Let's see what happens when we build and debug this. Now notice I have not explicitly set the length and the width. If I run it, it'll say 1 times 1 equals area of 1. So you might ask, well, where'd the 1's come from? Well, why are the length and the width 1 when I didn't specify anything? That's right. Inside of the implementation for the constructor here, I set the length and the width, the internal length and width, to 1. So when I call get width or get length, the width having not been set to anything else is 1. The length likewise is 1. Now, after that, I'm going to say my rectangle dot set length to 10, and then my rectangle dot set width to 25. Then I'm going to say, actually I'm going to copy all this exact code right here, which copy and pasting is usually not a good idea with code. It usually means you're doing something wrong, but for small pieces of code like this, it's not really a bad thing. It's okay, especially since we're learning. All right, so the first time around, it says 1 times 1 is area of 1. Next one says 10 times 25 is area of 250. The 10 comes from the set length. That caused my internal data member length to be set to 10. And then set width caused the internal data member width to be set to 25. And then I printed out the data, including the calculated area. So that's pretty much all you need to deal with classes. Again, we create a main file that has the main function. Usually I create the skeleton of that first. Then you want to create a header file with the same name as the class you're going to create. So for example, since the class is CRectangle, I call the header file rectangle.h. To create a header file, again, you do right click, add new item, make sure it's under header file, change it to whatever.h. You want to match the case also. I will take points off if I see a different name for the H file than the CPP file, or if the names don't match the class. Although C++, unlike a language like Java, which does enforce it, C++ does not enforce the class name having to match the file name. It is extremely poor programming practice to name it something completely different than the class that's residing in it, or at least the primary class you're focused on. So to implement things, you have to go into the CRectangle.cpp, and then you're going to include the CRectangle.h, do the implementation of each of these. Don't forget to do, for all the member functions, you want to preface them with the name of the class, and then the scope resolution operator, which is the 2 colons. And note that the return type is before that, okay? And then we want to fill in the bodies. All right, make sure that you get rid of the semicolons if you did a copy and paste job from here. Or you could just type them, it doesn't really matter. But just make sure there's no semicolons at the end of these like there are here. They're supposed to be here, but they're not supposed to be in the CPP file. All right, so this seems to be working pretty well here. You can create a different rectangle. I could say CRectangle, another rectangle, etc. So that's pretty much it. If you want a little bit of practice, I would say take this class that I've created here and add an additional member function and call it get perimeter. And you can look up the function, or the function. You can look up the formula for the perimeter of a rectangle. So 2 times length plus 2 times width. And then write the code for it. All right, so that's pretty much all I've got for you today. This is a lot shorter than the initial lecture that we had. Since in this class what we typically, I don't have interaction with you directly back and forth like I would in the regular class settings. The lectures that I actually record will tend to be a lot shorter. So I'm going to create a discussion board on the Desire to Learn site, and I'm going to try to insist that, or not insist, but I'm going to try to encourage you. In most cases, there may be actual assignments I give you on the discussion board, but in general, I'm going to encourage you to interact on the discussion board. When you get assignments, don't cheat, obviously, but it's okay to like ask general questions and things like that. Another thing, a lot of you have been having extremely serious problems, it seems like, downloading the Visual Studio. So I would recommend, if you have not tried it yet, go to dreamspark.com. Try to log in with your Oakland CC, student.oaklandcc.edu address, and let me know if you can download the professional version. A lot of you are just seeing the SDK, and that's not right. You should see something that looks like you're going to download the actual IDE, not just the SDK. So if you're having serious problems with that, I would say, for temporary measure, until I get a response from Desire to Learn, I did send them, not Desire to Learn, I'm sorry, DreamSpark. On the Hub's actually the company that manages their storage. So I did ask them what's going on, so hopefully I get an answer from them soon. But in the meantime, you can look up the Visual Studio 2012 Express edition, and you can download that. That's free. You don't need to get it from DreamSpark. You can get it from Microsoft's website directly. It's a little bit dumbed down, but it's similar to what we're doing here. It just doesn't have quite as many options. Okay, I don't think it has an option for start without debugging, but I'm not sure, or it's at least not default. So if you have any questions, please email me or communicate on the discussion board, and other students could help you, or myself, depending on when I pop in. And always keep an eye out for the news feed and email. Thanks, and have a great day.